to better understand how AI-powered search engines compare to traditional search. Researchers from Ruhr University in Bochum, Germany, and the Max Planck Institute for Software Systems conducted a detailed analysis. They compared the results from Google's standard search engine with its AI overviews and Gemini 2.5 Flash, as well as OpenAI's GPT-4o in web search mode and the GPT-4o with search tool. The researchers used a wide range of test queries, including specific questions from the WildChat dataset, general political topics from all sides, and products from Amazon's list of the 100 most searched items. This comprehensive approach allowed them to examine how these different search engines select and cite their sources. One of the most striking findings from the study was that generative AI search engines tend to cite less popular websites than traditional search engines. Using the domain tracker Tranco, the researchers measured the popularity of the sources cited in search results. They found that sources referenced by AI engines were more likely to fall outside both the top 1,000 and even the top 1,000 domains tracked by Tranco. For example, Google's Gemini search had a median source that was not even in Tranco's top 1,000. Additionally, 53% of the sources cited by Google's AI overviews did not appear in the top 10 Google links for the same query, and 40% were not even in the top 100. This means that AI-powered search engines are surfacing information from corners of the web that traditional search engines rarely highlight. But does relying on less popular sources mean that AI-powered search engines provide less useful or less comprehensive answers? The researchers found that this is not necessarily the case. GPT-based searches, for example, were more likely to cite sources such as corporate entities and encyclopedias, while almost never referencing social media websites. An analysis using an LLM-based tool showed that AI-powered search results covered a similar number of identifiable concepts as the traditional top 10 links, suggesting that the level of detail, diversity, and novelty in the results was comparable. However, the study also noted that generative engines tend to compress information, sometimes omitting secondary or ambiguous aspects that traditional search results would retain. This was especially noticeable for ambiguous search terms, such as names shared by different people, where organic search results provide better coverage, according to the researchers. AI-powered search engines have unique strengths and limitations. One advantage is their ability to blend pre-trained internal knowledge with information from cited websites, creating responses that can be both informative and concise. This was particularly evident with GPT-4o with search tool, which often provided direct answers based solely on its training, without citing any web sources. However, this reliance on pre-trained data can become a drawback when users are searching for the most current information. For trending topics, the researchers found that GPT-4o with search tool sometimes failed to search the web for up-to-date information, instead responding with requests for more details from the user. So, are AI-powered search engines better or worse than traditional search engines? The answer is not straightforward. The study did not make a definitive judgment, but it did highlight the need for new ways to evaluate generative search systems. The researchers urged future studies to consider factors such as source diversity, conceptual coverage, and how well these systems synthesize information. As AI continues to reshape the landscape of web search, understanding these differences will be crucial for users, developers, and policymakers alike.